All right, 7.2, applications of normal distribution. Start off with talking about z-scores again. Standardized. All right, so standardizing a normal random variable. So we're going back to our z-scores. Talked about that, I believe, in chapter 3. We introduced it. And now we're going to get into the application of it. So we have z equal to x minus mu over sigma, or in other words, your data value minus your mean over your standard deviation. All right. Let's see before I go to the problem. Yes. So let's look at the chart. Hold on, guys. Looking for that page number. I think it's a, yep, there you go. We wrote it kind of funky, A-11 and A-12. We need the chart. We will use the chart on pages A11 and A12 in the appendix. All right, so once we calculate our z-scores, let's talk about how we will read this chart. Let's say if we have the z-score of 1, 2, 3. And I should have mentioned up here, well, I'll just write it right here. Z-scores. So your z-scores will always be rounded to 2 decimal places. So we talked about that before when we were doing our calculations. So let's say if we have your z-score of 1.23, the chart that's in the appendix, and I'm going to pull it up before class is out and show you what it looks like. Starts off like this. All right, so it looks something like this. When it starts with negative 3.4 and it ends in positive 3.4. And then the top row starts from 0.00 and goes to 0.09. All right. So when I go back to, and I'll write this down a little further. If I have that z-score of 1.23, to find a value that coincides with that 1.23, I'll probably do purple. The 1.2, I will look for in this column, and the 0.03, I will look for on this row up here. So I'm looking for 1.2 here, 0.03 up here. And where they meet in the chart is the value I'm going to pull. So 1.2, 0.8907.
Oh my God, that has driven me crazy. I couldn't figure out where they were getting the numbers from.
Oh man, yeah. So we're gonna calculate. They will give us numbers in the problem, and we're gonna use this formula to calculate it. And so once we calculate it, we'll get something like 1.23, and then we'll go to the chart and get that from out of the chart. All right. Questions on what I said so far? All right.
Nope, I get it now. I just couldn't figure out where they were getting these numbers. I mean, literally, I stayed up to like 4 one morning trying to figure it out.
Oh man. So now also about this chart, they give you this diagram in the left corner. All right. So what that means is that this value, or whatever, let me say it like this, the chart value will always represent all right, so the chart value that you get will always represent what is to the left of the data value, or in other words, what is less than the data value. Don't don't forget, you if you look at a generic number line. Um, if I look at the number 1, all the values that are greater than 1 will be to the right of it. All the values that are less than 1 will be to the left of it. If I look at -2, all the values that are greater than -2 will be to the right of it. All the values that are less than -2 will be to the left of it. So what we're saying is, when we talk about less than, you're always talking about to the left of. Greater than, you're always talking about to the right. So the value that you get from the chart will always be what's to the left of. And now if you want to know what's to the right of that value, All right, so to find out what is to the right of the value, in other words, greater than, you're going to subtract the chart value from 1. Because remember, everything under that curve, we talked about last section, everything under the curve is equal to 1. So if you got 0.8907 is to the left, subtract that from 1, and you will figure out how much is to the right. All right. So I'm going to show you this chart before we actually get to a problem. But any questions on anything I've written? I think I actually have, yeah, I'll send you a copy of it. I think I already scanned it. I'll send a copy of the chart to you guys some point before the week is out. I'll try to do it today. But any questions before I switch to another screen? Everybody good? Everybody? Don't want to mess up anyone's writing. Yeah.
I'm good.
All right. Thank you much. So let's go to, where's my textbook? Oh, menu. Waiting for it to come up. All right, here we go. So once you get to the e-text, you should be able to type in here A11. Should take you to the chart. All right, here we go. So this is A11. It gives you the negatives. It's negative 3.4. I can move my screen. Negative 3.4 to 0. And so to go to the positive, remember we had 1.23. So I need the positive side. That's A12. So if you notice, you look at 1.2. And then if you were to scroll over, I can't write on the screen, wish I could, but if you were to scroll over to where 0.03 is.
0.8907.
Yep. So that's how you would read the chart. And like I said, what that represents is the amount of data that would be to the left of that data value. So if you want to convert it to a percentage, you could say 89% or 89.07%, would be to the left or less than. So you'll see the application in a second, but I just want to make sure you guys are able to read the chart. All right, so let's go back to the notes and let's do a problem. All right, so a pediatrician obtains the heights of her 3-year-old female patients. The heights are approximately normally distributed with mean 38.72 inches and standard deviation of 3.17 inches. Determine the proportion of 3-year-old females that have a height less than 35 inches. I'll give you a chance to finish writing before we do the problem. All right, so we write down our givens first. We know our mean, 38.72. Standard deviation, 3.17. And then the data value that's in question. We are comparing and we want to know what's less than or the proportion of females that are less than 35. So that's going to be our data value, our X. All right. Z-score is the data value minus the mean divided by the standard deviation. That would be negative 1.17. Questions on that part so far?
Not yet.
So now we go to the chart and follow the procedure that I showed you earlier. We will look for negative 1.1 on that column, and then we'll go to 0.07 on that top row. And where they meet should be at 0.1210. I guess I could have just did this. All right. So now we go back to our problem, make sure we're actually going to answer the question when we give the value that we give. The chart, and not the chart, but the problem wants less than. And remember the chart always give less than. So the chart value, if your problem asks for less than, lower than, below, they're just going to be keywords. And keywords is going to dictate less than, shorter. Anything that dictates less than, your chart gives that value. So that's what you will use. So you just use the chart value. And that means, let me see, do I want to give a proportion?
So if it was asking for more, do you just subtract it by 1?
Yeah, and I'm going to do an example of that as well. But yes.
Okay.
We subtract by the 1 if it's greater than the what's greater than 1, right?
Well, if this has said greater, then we will subtract from 1. subtract the chart value from 1. So if you had to write the answer in sentence form, the proportion of the pediatricians 3-year-old females who are less than 35 inches tall is 0.1210. Also, they could have said shorter than, like I said, anything that signifies, less than, then that would have still been okay, and you would have still followed the same process. All right, questions before we look at another one?
Nope. All right, so using the previous problem, find the probability that a randomly selected 3-year-old girl is taller than 37 inches. So once again, establish your given information. Our mean is 38.72, yeah. Our standard deviation, 3.17. And our data value is 37 inches. Follow the same procedure. Data value minus mu, your mean, over the standard deviation. So that's going to be negative 1.72 divided by 3.17. It's negative 0.54. All right. Questions before we hit the chart? So you go to the chart, look for negative 0.5 on that left column. I know I had it on the website. Let me go there. Sorry, y'all, waiting for my stuff to pull up so I can get that value. So negative 0.5.
And 0.4 is 0.2946. 0.2946. So you have to go to the chart to get that value. All right. And sorry, I hit the wrong button. Any questions so far? All right. So key phrase here is taller than, which is another way of saying greater than. So just a reminder, chart always give less than. To find greater than. So Noah said it already, but just writing the notes to reinforce. So the chart always give less than. So to find greater than, we will subtract the chart value from 1. All right. So once again, taller than is just another way of saying greater than. So we'll do 1 minus 0.2946. And that'll be 0.7054. So that would be the probability of randomly selecting a girl that is taller than that 37 inches. All right. Questions. All right. There are only 3 scenarios that you can come across, less than, greater than, and then this third one we're about to talk about. Outside of that, we just have to make sure you look at the keywords. Those keywords will direct you to either one of those 3 scenarios. All right.
Mr. Tucker,
Yep.
the chart you pulled up, does that work for all the problems in this chapter or just?
Yeah, it worked for all of them. Mm-hmm.
Okay.
Yep.
All right, thank you.
Not a problem. All right, so using the previous information, find the probability of randomly selecting a 3-year-old girl that is between 35 and 40 inches tall and inclusive. That means it can't be 35 and can't be 40. All right, so just like before, write down your given information. Our mean, 38.72. Standard deviation, 3.17. Now we have 2 data values. This time we have 35 and 40, so we're going to find the z-score of each one of them individually. I'll call 35 x1 and 40 x2. All right, so let's go. First z-score is going to be this setup. That's negative 1.17. And the second z-score, $40. 0.40. All right. So now we need to go to the chart. So questions on that before we go to the chart. Got two different z-scores, so we need two different chart values. All right. So let's get our chart values. All right, let's do it like this. That's going to be 0.12. 0 and here 0.65. All right, so you go to the chart and you should get 0.1210 for the first value, then 0.6554 for the second value. All right. Just want to show you this before we do what we do. So Z1, remember that represents what's to the left. And what we have for Z2 will be over here is further to the right. That represents what's to the left. Now, I want to know what's between the two. So if that's the case, what I would do is subtract this part from Z2, and that'll leave me with that piece. So whenever you're doing between, Let's say data values. So to find what's between data values, you would subtract the two chart values and make sure we're not subtracting z-scores. We're subtracting the chart value. So be careful with that. Remember, it's the chart value that we subtract from one, and it's the chart values that we're going to subtract from each other, not the z-scores. We are not doing any calculation with z-scores. We calculate with the chart values. So to find the portion between, we do 0.6554 minus 0.1210. 0.5344. All right, questions?
Sir,
Yes, sir.
you said not to do the z-values minus,
Mm-hmm.
didn't you?
Right, we're subtracting the chart value. So like when we go back to that one where we subtracted from one, it was the chart value, 0.2946.
Oh,
Yeah, not the z-score. The z-score helped us to find the 0.2946.
and what's the z stand for?
Z.
That's it? Okay.
That's it. Yeah, there's no super word for it.
I'm
It's just
done. I'm done.
yeah, it's just z-score. So if there is one, I haven't seen one. I just know it's normal. You know, this is how they normalize normally and standardize the data value, and it helps you to be able to compare your data values to other sets of data values. But yeah, I haven't seen a representation for what actually Z represent.
Okay, my military brain can't keep up with this.
It's a good question though. It's a good question.
Okay,
It's a good question.
thank you, man.
Yeah,
Sorry.
no problem. Not a problem.
I'm done. This class just gets better and better each session.
So to summarize your scenarios, remember I said there are only 3 scenarios. So if you can try to, you know, not try to make it too complicated. There are only 3 scenarios. You have less than, greater than, and between. Now between, for the most part, that's it's hard to find other words that represent between. But when it comes to less than, you could have shorter, just like you could have taller. Colder, you know, if you're dealing with temperature. So hotter, below, above, if you're talking about water levels or something like that. But anything that represents, you know, greater than or less than, those keywords will still hold true. Something less versus something greater. But there are plenty of examples out there. But what you would do is for anything that's less than, you take, or let me say, use, well, no, let's say chart value is the answer. Also, let me warn you that this chart, the z-score chart, if you Google z-score chart, you have to make sure that you actually have the same one that the book has. There are different z-score charts. They still give you the same answer, but you have to know how to use them. So this one is set up a certain way. There are other z-score charts that you could Google that will be set up a different way. If you know how to use them, you'll still get the same answer, but you cannot use the method that I just showed you because they're set up a different way. So make sure if you don't hold true to what I've told you, you use the book z-score chart or a chart that you've seen that looks exactly like the books. So just throwing it out there. All right. So those are your three scenarios. If it's less than, then you're going to use the chart value. The chart value will be your answer. If it's greater than, you're going to subtract the chart value from 1. And then if it's between, you're going to subtract the chart values from each other. All right. Questions?
Nope, no questions. But this definitely helped me.
Cool, cool. That's good. That's good to hear.
I
So,
sweated out a whole fresh perm on this one. I play.
so try this stuff out, guys. See if you have any questions. That's it for chapter 7. So, if you have any questions, next class will be that time to ask whatever you want to ask. I will not do anything new on next class. If you have questions, I'll address them. If you don't, I'll sit around. But if not, then we'll just call it a weekend. Call it a day. Head on to the weekend. So that'll be your class to do whatever you want to do with it. Anything before we close out?
Thank you, sir.
Not a problem. Not a problem. Thank you for coming through.
See
All
you
right.
Thursday.
Let's see. Yep, no problem. Thank you. Thank you. All right,
See you
guys. Have a
Thursday.
good
I'm
one.
out.
Say again.
I said, see you Thursday. I'm out of here. I'm
All right.
driving
Take care.
and doing my class.
All right.